Welcome to lesson 7.6 on geometric series. Our lesson goal for this class is to calculate the sum of a geometric series. So series has to do with sum. And we're going to do it for two different scenarios where we're given A, which is your first term, N, the number of terms, and also R, the common ratio, or given our first term A, our common ratio R, and then given the last term. So when we're looking at a geometric series, there's going to be two different formulas we're going to use depending on what they give us. And the first one is Sn, the sum of the first n terms, so n is our number of terms, is equal to A, that's the first term, times r to the n minus 1, close bracket, all over r minus 1, and that r is going to be our common ratio. So we're going to use that if we have a, r, and n. But if they don't give us the number of terms, we're going to use the second version of this formula, where Sn is equal to Tn plus 1 minus T1 over r minus 1. T1, that's our first term. And Tn plus 1, this isn't the last term. This is going to be the last term times, with one more step, so times r. So it's not the last term. And we're going to go down here. Tn plus 1 equals Tn times r. It's one more step after our last term. So depending on what they give us, we might use the first equation or we might use the second equation. If you're curious about how these formulas were determined, check out page 455 for all the gory details. In example 1, it asks us to find the sum of the first 10 terms of the series, blah, 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 using the first formula. Well, they've told us which formula to use. Very nice of them. So we're going to be using S of n equals A bracket r to the n minus 1, close bracket, all over r minus 1. And in this case, we know our first term, A, equals minus 3. The common ratio we get by taking the second term divided by the first term. So that's minus 5. And then n, they've told us it's for the first 10 terms. So that's our n, that's our a, and we figured out our r. When we substitute these all in, we'll get that the sum of the first 10 terms is equal to minus 3 bracket. On the calculator, we would do a minus 5 inside brackets, raised to the exponent 10, minus 1, close the bracket, divided by, r was minus 5, minus another 1. And when we add these all up, when I did it on the calculator, I did it in 2 steps, but you could do it all together. When I did it, I got 2, 9, 2, 9, 6, 8, 7, 2, all divided by minus 6, or that overall, the sum of the first 10 terms is 4,882,812. And that's the sum of the first 10 terms. Example 2. Find the sum of this series using this second formula. So a reminder that the second formula looked like Sn equals Tn plus 1. So that's not the last term, it's 1 after the last term, minus the first term divided by r minus 1. So we have our first term, that's 3. We have our last term. We know Tn is 1536. We can figure out what r is. R is our ratio. So in this case, it would be take the second term divided by the first term, 6 over 3. So our ratio is 2. We're going to use Tn to find Tn plus 1. So Tn plus 1 equals Tn times r. So that's going to be, our ratio is 2. So that's going to be 1536 times 2, which gives us 3072. So we have Tn plus 1 And now we have everything we need. We have T1, we have R, and we have Tn plus 1. And we put those all in the formula. And we can find that our sum, we don't know how many it's of, but S of n is going to equal 3072 minus T1, which is 3, divided by R is 2, minus 1. So we'll get 3069 divided by 1, or we get that our sum is equal to 3069. And that's going to be our final answer. Example 3. They don't tell us which formula to use here, but they ask us to find the sum of the series. They start it off, they give us our last term. So since they give us our first and our last, we're going to use that second formula. And that second formula, a reminder, was Sn equals Tn plus 1 minus T1 over R minus 1. Our first term is 64. So T1 equals 64. R equals T2 over T1, which is 32 over 64. We get that our R is 1/2. We've got our R, we've got our T1. So the last thing we're going to need to do to get is our Tn plus 1. If we know that this is our Tn, 1 over 256, then Tn plus 1 is going to equal 1/2 times 1 over 256. So Tn plus 1 is going to equal 1 over 512. So for all of this, we plug them all in and we find that our sum is equal to 1 over 512 minus our first term, 64, divided by 1/2 minus 1. So when I did that on my calculator, first it gave me, I did the whole thing all at once using the button, which is box over box, with your fraction button on the calculator. So the answer the calculator first gave me was a fraction. It gave me 32,767 over 256, or if you write it as a decimal, it was 127.996. So either one of these works as your final answer for the sum of that series. Last example, example 4, says that at a fish hatchery, fish hatch at different times even though the eggs were all fertilized at the same time. Number of fish that hatched on each of the first 4 days was 2, 10, 50, and 250 respectively. If the pattern continues, calculate the total number of fish hatched during the first 10 days. So since it's asking us to calculate the total number, that's the key word, that total number of fish, that means we're going to be finding the sum. And they give us our first, that's going to be our A. A is 2. They give us 10 days, so N is 10. We can calculate that R, which would be 10 divided by 2, so R is 5. We have all of this. We'll put it into the formula Sn equals A R to the n minus 1 all over R minus 1. So that S10 equals 2 bracket 5 to the 10 minus 1 close bracket all over 5 minus 1. And when I did that whole thing on my calculator and I did the mental math that 5 minus 1 was 4, I got that S10 was 4,882,812. And because they asked in words, I'm going to answer in words. So therefore, 4,882,812 fish hatched during the first 10 days. And that's it for the examples. The last thing we're going to do is just write everything down all in one place, all of our formulas for arithmetic and geometric sequences and series. So for the general term of an arithmetic series, that's Tn. It equals a plus n minus 1 d. For a geometric sequence, Tn equals a times r to the n minus 1. In terms of recursive formulas, we have to know that T1 equals A. That's true for both of them, the arithmetic and the geometric. So T1 equals A, and then Tn equals Tn minus 1, the term that came before, plus that difference. And for geometric, Tn equals R times Tn minus 1. For function notation, f at n equals a plus n minus 1d. And for geometric, f of n equals a times r to the n minus 1. Looks the exact same, except now we're using function notation. For series, that's the stuff that we just finished learning today. So for arithmetic, we have two different formulas. I'm going to write them down here. So the first one is that S of n equals n over 2 bracket 2a plus n minus 1 times d. That's the first one. The second one would be S of n equals n times t1 plus tn all over 2. Or you could write the n over 2 up at the front, which I think is how I did it in the notes. So I'm going to change back to that. So that's for the arithmetic. If we're doing it for geometric, you could write that Sn equals a bracket r to the n minus 1 all over r minus 1. Or the second one here would be Sn equals tn plus 1 minus t1 all over r minus 1. So having them all in one place should make your life a bit easier. And that's it for today's lesson.